Okay, Pierre, proceed.
Okay, can you guys see my screen?
Yes.
Yes.
Okay. Okay, good afternoon to my respectful supervisor, Mr. Lee Ching-meng, and to all my fellow friends. So today, I would like to proceed my presentation, which is about the ice and rain protection. So the ice and rain protection systems enables unrestricted operation in icing condition and heavy rain. For anti-icing, hot air or electrical heating protects critical areas of the aircraft. Ice and rain protection systems are the systems that are designed to keep atmospheric ice and rain from gathering on aircraft surface like propellers, wings, engine intakes, environmental control intakes, and rotor blades. Thermal anti-icing, electrical anti-icing, and windshield wipers are the systems provide for ice and rain protection. The anti-ice and rain systems include flight deck window heat, windshield wipers, probe and sensor heat, engine anti-ice system, wing anti-ice system, and ice detection system. Thermal anti-ice use engine bleed air from the compressor carried in ducts to heat the engine intake lip and the three inboard slats. Duct is a system that used to circulate air for heating and cooling. So as you can see, this is the anti-ice component diagram. It is consists of the alpha vane, window heat, windshield wipers, engine cone lip, and leading edge slats. Next, it is the flight deck window heat. So the flight deck windows numbers 1, 2, 4, and 5 consist of glass panes laminated to each side of a vinyl core. Flight deck window number 4 has an additional vinyl layer and acrylic sheet laminate to the inside surface. So flight deck window number 3 consists of 2 acrylic panes separated by an airspace. So this is Windows number 1, and this number 2, this number 3, and this is number 4 and 5. So a conductive coating on the outer glass pane of window number 1 and 2 permits electrical heating to prevent ice buildup and fogging. A conductive coating on the inner glass pane of window numbers 4 and 5 permits electrical heating to prevent fogging. Window number 3 is not electrically heated. So this is the flight deck window heat operational. So the forward window heat switch just control heat to window number 1. The side window heat switches control heat to window number 2, 4, and 5. Temperature controllers maintain window number 1 and 2 at the correct temperature to ensure maximum strength of the windows in the event of bird impact. What is the meaning by bird impact is it is a collision between a bird and an aircraft which is in flight or on a takeoff or landing roll. So power to window number is detected. A thermal switch located on Windows 5 opens and closes to maintain the correct temperature. There's a windshield air or Windows number 1, and it comes from the air conditioning system. So the windshield air, it is using the blade air to hit the windshield. So the process involves taking hot compressed air from inside across the windshield. Next, it is the windshield wipers. So the windshield wipers, it is a device to remove rain, wash fluid, water, so it can better see ahead. The rain removal system for forward windows consists of windshield wipers and a prominent rain repellent coating on to maintain a clear area on the cockpit number one windows during takeoff, approach, and landing in rain or snow. The windshield wipers should not be used on a dry windshield. These bigs operate on a dry windshield. So each wiper is operated by a separate system in the event of a system failure. So the switch provides a selection of speeds and controls the stowing of the wiper blades in a parked position when the system.
Nazrul,
Yeah.
I have a question about the material for number 3. Why is it different?
Material number 3.
The previous slide, kan? Previously. Okay.
Please.
Why is the material used for window 1?
Why? It's the how the window is heated.
Oh,
Which part of the window is heated?
okay, sir.
My question: which part of the window is heated?
It is number 1, 2.
Yeah, there is the window, but how is it heated? Which part of the window? Let's
Yeah.
say number 1, window. How is it heated? Where is the heating go? How many layers are there in number 1 window?
Well,
Yeah, you didn't explain how is it. That is the main thing that I give you this subject, that for window, you have to explain the construction and how is it heated. Not number 1, number 2, number 3, number 4. We just need to know how the window is heated. Right? They say the flight deck window is heated. Okay. How is it heated? Right? How the electric current will hit the window. Right?
okay, sir.
Am I continue? You have to follow up, write this in your follow up.
Okay, sir.
You can explain when there's a time for it.
Okay, sir.
Because I'm sure that nobody know how the window is heated. If there's no electrical power supply to them. Right?
Okay, sir.
Yeah. Like your car, how the back of the car is heat to prevent fog. You
Yes, sir.
see a lot of strip there at the back of your car, kan?
Yeah.
Yeah. So that is helping you to hit the glass. But how is this aircraft window is heated, especially on the windshield? Right? And why is it heated?
Yes, sir. So can I proceed to next slide?
Yeah, sure.
So next, it is the probe and sensor heat. So the pitot probes, it is a flow measurement device that used to measure temperature. Probe and the alpha vents are electrically heat, but the static ports are not heat. This is because the static ports, it is electrical heating elements that prevent ice accretion and water ingestion, ensuring the performance of primary flight instrument that is not degrades even under the most severe atmospheric condition. So if an alternative static port may be located inside the cabin of the aircraft as a backup for when the external static port are blocked. So when operating on standby power, only the captain's pitot probe is heated. However, the captain pitot lights does not illuminate for failure. The standby power means the power converter that is used to convert battery voltage into AC voltage in a standby power system that is sitting in an off state waiting to turn on in the event of a power line failure. So it enables a device to switch on very quickly without delays. So this is the probe heat panel. So if the probe heat lights is illuminated, means the probe is not heat. And number two, it is the probe heat switches. If the switch is on, means the power is this power is applied to heat related system, and if it off, the power is off. And this is the third test. If we push, means the electrical power applied to temperature probe on the ground. The temperature probe, it is a type of sensor which is used to measure temperature. Uh, it it is measuring the change in resistance of the given area, which is solid, liquid, gas, and convert it into a usable format. Yeah. This is the ice detection system. So an ice detector, it is an instrument that detects the presence of ice on a surface. The ice detectors are used to identify the presence of icing condition. So the system consists of a probe located on the forward left fuselage, and probe sense ice build up in flight. The icing lights illuminates. Then when ice has previously been detected and the probe is no longer detect ice, the the icing light will extinguish and the no ice light will illuminate. So the icing lights and the no ice light do not illuminate simultaneously. The ice detector light located on the forward overhead panel. It will illuminate if the ice detection system fails. Illumination of the ice detector lights also illuminates the master caution and anti-ice systems and initiator lights in the cockpit. This is the ice ice detector panel. If it is illuminate, means the ice detector is detect the ice. Number two, it is the no ice lights. If it is illuminate, means the ice detector is not detecting any ice. So in order to extinguish the lights, need to push the button. So far, do you guys have any question?
Nazrul, same question. How is the pitot tube heated?
Well,
You are explaining all the light and indication, but you didn't explain how is it heated. We only know that the electrical power goes through the thing, but how is it heated? Huh? Anything? How is it heated? How's the power going to change to heat the thing? What element is used?
I think I missed the schematic diagram for the probe.
Yeah, the basic function now you guys learning is, okay, we supply the electrical power there.
Yeah.
How it hit the window, how it hit the pitot. We don't have to know the indication is just a bonus that, or there's an indication once we on it. And macam your aircon, you press the thing, or other aircon light. So now we know aircon is on. But how the aircon works? Same thing is like your car heater, we press it. We press the thing to give the electric supply to the heating element. How is it heated? We don't know. Right? That's why I asked to learn about the basic. How is it? If you tell about pitot heat, how is it heated? Okay.
Okay, sir. Okay, sir.
So now we will explain everything. We know the switch, we know the lights, but we don't know how it's heated for the window and also for the probe or sensor. Right?
After this, I will add the schematic diagram and the slide.
I have to explain.
Yeah.
If not, everybody is like, okay, electric power, okay, it's heated. How is it? Macam kettle we use what? We also supply, but how is it heated?
Yeah.
Right?
Okay, sir.
Okay. On the ice detector, okay. If the ice is formed there, how are you going to capture and turn? What are the system that work to tell you that ice is formed there? We only know like the light will illuminate
Yeah.
and the caution light is there. But how does the sensor work? We don't know how the sensor works. If I put ice there, right? How does the sensor work? Does anybody know how the sensor work? How the sensor, the ice form there on the probe, how can it translate to a signal to tell the light to be on? What is it using? Right? So we also don't know how it works. We only know other eyes, other light. No ice, no light. But how the sensor work, I don't know. So you have to,
think after this,
explain if the ice form there, what happens, and at the end you will trigger the light. How it trigger the light, I also don't know. Right? Okay,
Okay,
let's
sir.
see some of it first. Continue.
Okay, next, it is the engine anti-ice system. So, engine bleed air thermal anti-icing prevents the formation of ice on the engine collet. Engine collet means it is the covering of the aeroplane's engine. The cooling used to streamline the airflow outside of the aeroplane. So it is used in so the engine needs airflow in order for them to cool down it. So the engine anti-ice operation, it is controlled by anti-ice systems, may be operated on is electrically controlled and switched to on. It allows the engine bleed air to flow through the cold anti-ice valve for cold lip anti-icing for icing condition. So minimum maneuver speed bars on the airspeed indicator. What is the meaning by stick shaker? Noisily vibrate the control yoke of an aircraft. So it will warning the flight crew that an imminent aerodynamic stall has been detected. So if the cold anti-ice valve fails to move to the position indicated by the engine anti-ice switch, the cold valve open lights remains illuminated bright blue and an amber thermal anti-ice indication illuminates on the control display unit. So the amber cold anti-ice lights illuminates due to excessive pressure in the duct leading from the cold anti-ice valve to the cold lip.
Nazrul.
Yeah.
Okay. Let me see your slide first. Next slide. Next slide. Next. Next.
So,
That's all.
yeah, explain the ice system.
Why you're explaining all the lights? You're not explaining all the function. How is it hot? How is it? The anti-ice system. How the bleed air go to anti-ice, the cowling. Anybody know what is cowling? The cow.
Cooling is it the covering of the airplane engine, isn't it, sir?
Do you have a picture?
No.
Yeah. So everybody haven't seen the aircraft. All this diagram you are showing
sir.
is talking about the light actuation. It's not showing all the flow of the schematic flow for the ice and rain protection. Right? It's a very simple that, right? For rain protection, we have what? Wipers and the thing, right? For the ice protection, what do we have? we have heating for the windshield. We have heating for the cowl, leading edge of the aircraft, pitot system, and others what you can find. So for the anti-ice system, there are two types. One is de-icing, one is anti-icing. What is de-icing? What is de-icing? I think you have to redo everything again. This is not playing the light. It's no explaining how it works.
Oh.
How's the cow how the cow is heated? Nazrul? Is it by electrical power or what?
Actually, it is the air from the pneumatic system.
Pneumatic system.
Yeah.
Are you sure it's pneumatic system?
Yes.
No. How the pneumatic system gonna go? Okay, you say pneumatic system. How it works? Here you only show you on off switch only the diagram. What you guys should be interested is how the system works, how each of the thing works, right?
Yes,
You are all showing the lights. Oh, this light come on, this light come on. No power, no light. The valve not working, the light will come on. But it's an anti-icing system, right? Anti-ice. So what does anti-ice mean? Nazrul?
What meaning by anti-ice? So the activation before the aircraft enters icing condition to prevent the formation of ice.
Okay. What is de-icing?
De-icing it means nyabuko in Malay it's said nyabuko.
Yeah.
The aircraft can only be de-icing on the ground.
Are you sure? So I need you to redo this,
Yes,
right? The soft
Okay.
ice and rain protection, right? Ice protection is there's two types: anti-icing and de-icing. Which of the system in the aircraft or which of the component in aircraft use anti-icing, which use de-icing?
Okay, sir.
The leading edge also can be de-icing. The intake of the engine also can be de-icing, right? This one is a larger turbine engine. This is an anti-icing system, right? So air from engine is hot. That's why the hot air will go to the anti-ice system, and all the lights, all these things, why is it come on? Right.
Okay, sir.
Other than that, I don't think all they know is switch on the light or for what. Switch on this switch is for the anti-ice. But how it works, nobody knows. Right? Okay, we have to redo
Okay, sir.
everything. So for the benefit of everybody, that this is type of thing that you
Okay.
guys should do in the future. When I say system, what is the system like, the flow of the system and how it works, right? Not tell me all the lights and everything. Okay. Next is who?
Okay, sir.
Evelyn.
Yes, sir.
Yours already ready?
Um, I have to edit a few more, sir.
Edit a few more. Okay. Let me see your slide.
Okay, sir.
While you're preparing the slide, I'll set this. Ryan,
Yes, sir.
okay. Before this, since the increase of the COVID case, right, I'll prefer you guys not to visit the hangar now, right? Stay home, stay safe, priority. Okay. So we'll go through all the thing online first. Don't go to a hangar. Reduce traveling. Okay. We'll arrange some other days for you guys to go hang out. Okay? Okay, you guys?
Okay,
Okay,
sir.
sir.
Yeah.
Okay, sir.
Okay, sir.
Okay, Ryan, your favorite subject, I want you to explain how engine works. The basic engine, like that day you explain,
Okay, sir.
right? How engine works and of course can be self-sustained.
Okay. Okay, sir.
Evelyn, your slide still not ready?
Oh, wait, sir. I need help from Nazrul.
Okay, send them first. Okay, Shahida,
Yes, sir.
what subject you are good at?
Subject.
Yeah, you are interested at. Last time you
Related to
do,
aircraft.
yeah,
Last
of
time
course.
I do about electrical system.
Okay,
Yeah.
electrical system. Okay. Electrical system.
Yeah.
All right. Okay, I give you a other one. Okay, I give you a harder one. Okay, Ryan.
Yes, sir.
Ryan.
Yeah, sir.
Ryan.
Hello.
Ryan there. Okay. For the to start off the engine, I need you to present your hello.
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 Hello, sir.
Can you hear?
Yeah.
Ryan.
Hello. Sorry.
Yep, go ahead. Yeah. So when next week we start into NG, you will present first. Hello. Yeah. Can you hear? Can you hear? Or may you do your computer first? Okay, Evelyn. Let's go through your slide first. Nazrul, next slide. Wait, slowly. Next. Okay. Wait. Next. 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 Okay. Next. 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 Okay, start again. The second slide. Next. 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 Okay, next. 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 Okay. Next. Okay, stop there. Evelyn, why you didn't explain the VHF and HF? Evelyn, guys, can you hear?
Yes, sir.
Yeah. On this part, I bet there's you mentioned the VHF, HF. I know it's at the back there. Try to arrange it. This is the most important, VHF is the most important communication there. Right? Some more?
Uh,
Next. Azul? Next. 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 You explain at the back here. Try to put it in front there. This is the most important. Okay, next.
okay, sir.
Our class system. Okay, go for info. Next. Next. This one, okay. This one for our class. Next. Right. So go 45, 50 minutes. Hafida, yours?
Oh, yes, sir. Sorry, I'm not ready my laptop for that because I'm using my phone for this session.
Okay.
Yeah, if I'm going to connect it, it's going to take a lot of time. I'm sorry, sir.
Okay. All right. So we do what we have. Evelyn, you can start for 15. We just go 50 minutes.
Yes, sir.
Yeah, proceed.
Next. What is a communication system? On an aircraft, the communication system is responsible for transmission and reception of information. This information may be in the form of voice or in the form of data. This system should be able to manage communication outside the aircraft, which is from the aircraft to the station or with another aircraft. It should also manage the communication in the aircraft, which is via the interphone, for communicating with other crew members or to make announcement in the cabin. Next. The communication system is managed by an audio control. This unit is responsible for receiving information, antennas, microphones, and sensors. It is then responsible for processing this information, transmitting them to specific locations such as headset or in the cockpit or in the cabin. In the previous slide, in the cockpit, the crew can manage the audio control unit with the help of audio control panel. Next. Control unit receive information from different sources, such as from the intercom that is used for internal communication. It receives audio information from the communication or navigation radio from the system. It may also be linked to some critical system aircraft in order to trigger onboard alerts in case of after processing the received data, the voice is sent to speakers or headset for the crew members. This unit will also send all the audio data to the cockpit voice recorder, which will record all this information. Next. The audio control panel allows the flight crew to select and control the received audio. From this panel, the crew may select for heads-up channel for communicating with the ground station. They can also interphone for communicating with other crew members, or passenger address or PA system to address the passenger. The audio control panel also has switches that we use to turn the system on or off, or to adjust the volume of the headset or speaker, and for transmission of audio selected channel. The audio control panel have transmitter selectors and with switches. A transmitter needs to be selected first to speak on any radio or interphone. The receiver switches function is to allow radio to be directed to the airplane flight, deck, speaker, headset. The receiver switches also control the volume, headset, and speaker. Next. The audio control panel can operate in two modes, is alternate and normal. The alternate and normal switch controls the operational mode. The normal position is used for fully serviceable audio control panel. If the audio panel or the remote electronic unit fails, the captain set normal switch to alternate. Next. So when the alternate normal switch set to alternate, the captain system is now operates in degrade mode. Degrade mode means that the audio channel is inoperative and the crew member can only communicate through one using mask and boom microphones. To transmit, the push to talk needs to be moved to the radio transmit position on the audio channel, or mic position on the control wheel, or the hand microphone.
What is PTT?
To talk.
Okay. So far, any question from you guys?
No, sir.
Okay. Proceed.
There are two interphone systems, which is flight interphone and service interphone. Flight interphone, my purpose is to provide private communication between flight crew without into service interphone system. The ground crew may also use interphone through a jack at the external power receptacle to talk to the flight deck. The second interphone system is the service or attendant system. It provides intercommunication between the flight deck and ground personnel. The flight attendants communicate between flight attendant station or flight crew using attendant handset. The passenger address or PA system is used to speak to make announcement to the passengers. The flight crew can make announcement using passenger address handset, attendant microphone, the related audio control panel. Call system, but the call system is used as a means for various crew members to gain the attention of other crew members. It also used to indicate that the interphone communication is the attention is gained through the use of light or signals such as chimes or horn. This system can be activated from flight deck, flight attendant station, the ship, passenger seat, or external power receptacle. Next. Okay, VHF or very high frequency communication. These systems are employed for controlling air traffic. This installed so the pilot may be given information and direction, may request information from air traffic control center, control tower, and flight service station. On the approach to any airport, the pilot aircraft calls the tower and requests information and instruction. High frequency communication. HF communication system are communication systems and are not employed on all aircraft. This system provides an exchange of communication between aircraft and from aircraft to the ground station. It's usually used on larger aircraft that require expectation range. Okay, now let's take a look how data communication takes place.
Okay. Any questions so far? No question?
No question, sir.
Okay. Evelyn, we will stop here. Right. So for tomorrow, I full day have a meeting. So we'll continue on Friday. Right?
Okay, sir. So
Friday.
start here.
Yeah, you stop here. Friday we will start early. We try to finish all what we have. We start at 2 o'clock. Right? Friday we start at 2 o'clock and try to finish everything. All the Evelyn on the ARCA system, Nazrul on the ice and rain protection, Hafida on the hydraulic system.
Yes.
Okay. So tomorrow I'm not free, so you continue on Friday.
All right, sir.
All right. And to get a head start, Ryan.
Yes, hello, sir.
Yeah. So your task will be on the engine, how the engine works.
Oh,
The three main component, how to make the engine, turbine engine works.
okay, sir.
Explain it so they will know how the engine will be self-sustained. Right?
From engine starting until it self-sustain.
No. Just explain the engine flow.
Oh, okay.
Engine starting, I will leave it to Shahida.
Oh, okay, sir.
So Shahida, since you know about electrical power, so explain how we start the engine.
How is that the engine?
Yep.
Okay.
Either by electrical power or a start.
A start.
Yeah.
Okay. Is it included the three main components in engine?
What do you mean?
Is it including the three main components in engine?
Three main component.
Yeah.
What
Got
is
it?
that?
Because you said just now there are three main components, right, in engine. So do I need to include that also?
No, that one will be explained by Ryan again.
Oh, okay.
How the engine works. Compress, combustion,
Okay.
and what is it?
So,
Turbine. Is it? I can't
Okay,
remember. Yeah.
okay. So
That's
I
how the
just
engine will how engine works. Right. To give you the thrust and also how the engine will rotate by itself. Right. But to start the thing, you need to start the engine. So you need to, once you finish, you have to explain how this engine is started by.
okay.
Whether we use electrical power, go to where, definitely is a start starter, right? Either it's a electrical starter or a starter, right? So by this, then it continues how to turn how to turn the engine, right?
Okay.
Because Ryan will talk about the component, how the engine turn, and then how the combustion works, how the thing. And okay, Ryan?
Oh, okay, sir.
Yeah. Okay.
Okay.
Right.
So,
See you guys on Friday.
So the
Right.
presentation sequence
Alright,
are
thank you.
the same, sir?
No, you first.
Oh, okay.
Yeah, you have to explain how the engine works. Then only Shaida will explain how to restart the engine.
Oh, okay, sir, understand.
Okay,
Uh,
sir.
which part of the engine will turn for the starter will turn. Right.
Okay.
Right.
Okay.
So you guys can share your notes, Shaida and Ryan. Talk to you
Okay.
between you guys. Right.
Okay, sir.
How we
Okay, sir.
want to explain. Okay. Right.
Alright.
Okay,
Okay.
sir.
Go to go. Right.
Okay,
Okay.
thank you,
Bye.
sir.
Okay, thank you, sir.
Thank you, sir.
Awal betul ke aku cakap thank you tadi?
Kejap.
Jumaat lagi kan, esok tiada kan?
Tiada.
Esok tiada.
Okay, see you guys.
Jadi jumpa.
Ya,
So
Jumaat.
nanti hari Jumaat Evelynda dulu, baru saya, baru Hafidah kan?
Ya.
Ya, sambung
Mungkin
si
gitu
April
lah.
kan?
Ya. So nanti saya tambah bagian tu anulah explain system tu. Nanti saya bagi baliklah slide yang baru.
Okay,
Okay,
well, steady.
Oke.
thank you.
Okay.
Thank you
See you
semua.
guys hari Jumaat.
Right.
Bye.
Okay.
Bye-bye.
Bye.
Thank you guys.